So, good afternoon. The topic of this talk is just how to explore the Python interpreter. Why this talk? Because in Pycon UK and Pycon US, I wanted to start to become a new contributor of CPython. And so, how to find your path in the labyrinth? Firstly, I'm Stéphane. Nice to meet you. I'm a simple Python developer since 2001 from Charleroi in Belgium, the place where the first EuroPython in Europe. Okay, how to start? Good question. Firstly, maybe with a documentation. But where is the documentation in Python? Maybe in the doc directory. In this doc directory, you will find the language reference, where you can learn the language programming, the programming language, sorry, and the library reference. If you want to use a standard library, is the right place. If you want to extend or just learn the CPython API, you have the documentation. So, and of course, you have the dev guide. The Python executable, where you run the executable, is just a small file of, 100 lines of code. And this executable is calling the Python library. So, by the way, you can embed your favorite language in your project, in C or C++ or with Java, just C and C++. So, here is the structure of the Python project. You have the grammar directory, where you can find the grammar and some other stuff, but mainly the file for the grammar. The lib for the Python modules, the standard library is there. The modules is just for the C modules, by example for the POSIX, for the everything where you can find a specific code for the operating system or for the platform, or just because you want to have some speed modules. The object, the built-in object for the bool, the dict, the set, the list, everything where you can find that. The parser, the grammar for the grammar, the lexer, the parser, and the compiler. And of course, the Python directory is the virtual machine. Of course, when you will compile Python, you will have a libpython file, libpython 3.5, a DLL or a dilib or a SO file. So, I have one question. Firstly, what's the result of Python C x equal 2 or 2? Who has the response? The response is just the command line, the lexer with the tokens, the parser with the AST, the compiler with the bytecodes. Of course, the interpreter is the runtime and the standard library. This part will be shown in this talk. The command line. When you execute Python, you will run the python.c, a little file of some lines of code. This file will call the library. This library will initialize the runtime and start to execute the lexer, the parser, the compiler. Okay? Just these points are really interesting. It's the path if you execute the previous command. Okay? You want to learn, it's the right way. Okay, for the lexer, you have an expression. From this expression, we try to create a list of tokens. A token is just an information. You have the value, but a keyword, a numerical value to specify what is the value. It's a keyword, an operator, a name, a symbol, everything. So, from this lexer, you can see that I just gave the right function and the right file where you can start to learn. From that, you can modify and, for example, add some new keywords in Python. How about the parser? The parser will take this list of tokens and create an AST, just a tree, where you can execute some operation. I will show later. In this case, we can see that we will read an object, so an expression. This expression will be translated in a list of tokens, and these tokens will be used for the parser. It's just an example. I create a dump of my expression. I receive this information. It's used by PyLint. It's a tool to, sorry, it's me? I don't know. It's used by the PyLint project, where you can learn it and try to improve your code, source code. How about the compiler? The compiler is just a small example. It's an emitter for the bytecode from the source. You explain, I want to have this expression, and I receive a list of bytecodes. The bytecode is just a lot of compact numeric code, portable, because you can use it on Windows, Linux, and the rest. And 1 byte can be followed by optional parameter. We will see that, example, when you want to add 2 numbers, number 1 or 2, but the binary add function, opcode, will use 2 parameters. And of course, it's used by a software interpreter. Some bytecodes. You can see I show the first ones popped up in route 2, and for the last thing in Python 3.5, set up async with. Okay? If you are really interested by the opcode, you can go in the include directory opcode file. You will have a good list for this opcode. So, the bytecode, sorry. When you create an empty file, an empty Python file, and you use the this model, you can have a small bytecode, 2 elements of the bytecode. Example, load const a return value. The first line will try to load a constant from the local frame, and the return value will return the value from the top of the stack. Another example, we define a function where we increase the value of the parameter and return it. Here is the example of the function with the disassembler. Load fast, load const, binary add, store fast, load fast, return value. So it's not a real complicated function, but we can see that there is the bytecode. We have the compiler, but sometimes when we try to learn the bytecode, that's very funny to see that with an empty line, an empty file, you have a result. But with the Peepholer, it's just a small part of the compiler. You give it a lot of bytecode, and you will receive another version of the bytecode. This Peepholer will optimize the bytecode, not the ST, just the bytecode. A small example: you have 2 more 2. The Peepholer will create a new bytecode with 4. Not 2 more 2, but just 4, the numerical value. And we'll remove the dead branch. Example, my previous example, 2 more 2, load const. You can see that on the first line, it's not 2 more 2, but just 4. It's a small optimization of the system. In this example, we load the constants. We store it in X, load the constants, and return it. Okay. But when we want to test the P, if 1 is true, of course, print hello. We can see that we load the name, the function, the symbol, and the stack. The load const, hello. Call the function, donc print is a function with a positional parameter, and we return the value with the pop. So, but what happens if is equal to 0? Nothing. We remove the code. It's a dead branch. Okay? It's a small optimization of the Peepholer with the compiler. So, about the interpreter. or how to give the life to your code. An interpreter is just a virtual stack machine. In the case of Python, it's not a register machine, just a stack machine. We will execute the bytecode, and here is a small example of a custom bytecode. Okay, push 5, push 3, push 10, add, pop. On the bottom, we can see the stack. When I pass to the next step, I will add 5 in the stack, in the bottom of the stack. I continue, 3, I will have 3 and 5. For 10, 10, 3, 5, okay? For the add, in fact, in the system, I will try to remove the two the two recent items from the stack, and we'll add it. Sorry. So, for the next point, just add the previous value, 13 and 5, and we will get 18. And now we can pop. We will have an empty stack. A small example about the basic virtual machine. You can write this virtual machine. So we can see that we have a stack here, sorry, and the loop for the running when we want to execute the interpreter. This loop will eval each instruction from the memory, from the stack. And the eval is just this code. It's not really difficult. In fact, for each keyword in my bytecode, I will execute the right function. In this case, I will eval push if I have push in my instruction. I will execute add if I have the add keyword, and the pop and the halt. So in this case, for the add, we can see that we will use the stack and try to pop each item for the left and the right operand for the instruction. So do you remember the code about the function? In fact, if you use the this, we have the bytecode. But the bytecode is very interesting because if we want to and push it on the stack. The load cons will get the value, the constants from the frame, and push it on the value on the stack. For the binary add, I will get two values, two PyObject, and just execute it. If I use a PyUnicode, if I'm example, try to make a string formatting, this code will be used. If we want to execute a modulo with two numbers, we will use this code, okay? So, and we have the store fast. The return value is not really difficult. And of course, if you want to read the rest, there is the ceval.c file in the Python directory, but the interpreter, just the interpreter, the loop of the interpreter, is a small function of 2,700 lines of code. That's very funny when you want to debug it and function of your platform and function of the parameters on the configure file. Okay. So, the summary. I know it's very quick, but how to contribute? Firstly, create a user account on the bug tracker. Secondly, sign the contributor agreement for the PSF. Naomi has explained this morning the behavior of the contributor agreement. Read the dev guide, of course, the documentation. After that, you can try to improve the current documentation because we need some help. Fill the issue if you find a bug. That's the case with Python 3.5. Test the proposed page. Write some pages, bug fix and feature, and you can be a little bit stressed because sometimes you have to wait 6 months before a review. It's true. Some bugs, we have some bugs of 3 or 5 years. Thank you.